The views expressed on Skeptically Speaking are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
Bring it on! The skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is. Cause we're skeptically speaking.
Hello and welcome to Skeptically Speaking. I'm your host, Desiree Shell. This week we're talking about cancer, its forms, its causes, and its most promising treatments. A little later on, we'll discuss the state of breast cancer screening and awareness with science writer Kayt Sukel. But first, let's take a slightly broader view. I'm joined by two guests today. We have Brendan Harley, assistant professor in the Chemical and Biomolecular Engineering Department at the University of Illinois at Urbana-Champaign. His research focuses on developing material platforms to study the initiation and progression of diseases like cancer. He's the partner of a previous guest on Skeptically Speaking, Dr. Kate Clancy. Great to have you here, Brendan.
Thank you very much. Great to be here.
And returning to the show is Dr. David Gorski, surgical oncologist at the Barbara Ann Karmanos Cancer Institute in Detroit, Michigan. He's also the managing editor of the very popular Science-Based Medicine, a website that explores the issues and controversies in medical science. Welcome back, David.
Great to be back.
Now, when people discuss cancer, it is often presented as one disease, like multiple sclerosis or heart disease, but that's not the case, correct?
Oh, quite correct. It's dozens, if not hundreds of diseases, which is why the whole concept of, quote, a cure for cancer, unquote, is kind of not a very useful concept, although it's a common misconception.
So when we talk about cancer, then we're really talking about a group of diseases with similar behaviors?
Pretty much, although there's a great deal of biological variability even within individual cancers.
So what are those characteristics then? What makes something a cancer?
Well, there's several characteristics that mark a cancer. One is uncontrolled proliferation. The cells keep growing inappropriately. I mean, there are a lot of cells in the body that grow pretty fast, but they stop growing when the signals tell them to stop growing. Another is an ability to evade the immune system. Another is the ability to break out of their basement membranes and invade into surrounding tissue. The ability to get into blood vessels and lymphatic vessels and metastasize is another. The ability to cause a blood supply to be brought into them, in other words, this is the process of angiogenesis, is also necessary. Without the ability to cause angiogenesis, a malignant cancer can only grow to maybe 1 millimeter or 2 in diameter before it outstrips the diffusion of oxygen and nutrients in water.
Well, now, I've heard people say that we're seeing increasing cancer rates, which is kind of a broad statement, but is that true?
Depends on which cancer, actually. Yeah, I mean, some cancers have increased incidence. Some cancers have decreased incidence. My specialty, for instance, breast cancer, is actually starting to show decreased incidence over the last 10 or 20 years, which is contrary to the common perception in the population. Most cancers are actually fairly stable these days if you adjust for age. What might be accounting for some of this is most cancers, at least the solid cancers, are diseases of old age. And as we live longer, more of us live long enough to get cancer.
And since we have so many, an aging demographic right now, you think that has something to do with it?
Well, I think it has something to do with the perception. As I said before, when you adjust for age, the changes up or down are not that dramatic for most cancers.
So are there more cancers now? Like, are we seeing cancers in places that we wouldn't have seen them before?
That's a great question. And so some of the stuff I want to make sure to defer to Dr. Gorski a little bit as well. But my understanding of a lot of this is that, we're improving from the technology front, which is the area that I work in a lot, the ability to find cancers earlier and detect nuances between what may otherwise have been lumped together as one form or the other in earlier days. And so I'm sure there are slight population shifts in terms of the types of cancers you see, but one of the things that comes up is how are we able to detect them and can we detect them earlier? And that may lead to shifts in perception again in terms of whether there's more or less of certain types, or whether there's a burgeoning number of cancers where it really is our ability to just detect the differences between what previously hadn't been able to be detected.
Okay, well, let's talk a bit about causes. Are there things that we know cause certain cancers beyond a shadow of a doubt, and other things that maybe there seems to be a link to, but perhaps there's not quite the evidence to back it up yet?
Well, smoking is the obvious one. Smoking causes multiple cancers. It's associated, obviously, with lung cancer, but it's bladder cancer, pancreatic cancer, a whole bunch of other cancers. So, like, smoking is one of the most unhealthy things that people can do as far as cancer goes. And that's not even counting its contribution to heart disease. So
I think that one hopefully has been drilled into people's heads. But are there other things that absolutely, undoubtedly cause cancer? And what I'm thinking of is the International Agency for Research on Cancer and the U.S. National Toxicology Program. They developed a list of known and probable human carcinogens. And the list is broken down into groups. We have Group A, which is carcinogenic to humans. Group B, likely to be carcinogenic to humans. Group C is suggestive evidence of carcinogenic potential. Group D is inadequate information to assess carcinogenic potential, and Group E is not likely to be carcinogenic to humans. So how does something make the A, B, and C groups?
a lot of it has to do with epidemiological studies. The links, they basically rate them on how strong the links are. Now, I'm not an expert in the epidemiology of cancer causation, so I can't get into too much detail, but I mean, basically there are certain chemicals that are associated with certain cancers, and these range from strong evidence that these cause cancers to weaker evidence. I mean, some of these are actually viruses. For instance, a group 1 carcinogen is the Epstein-Barr virus. Of course, and then there are other things like diethylstilbestrol. I always forget how to pronounce that. And some other things like the hepatitis C virus, which is and hepatitis B, which both can cause liver cancer. And radioactive products, which are fairly clear that they can cause various cancers. But it's basically mostly epidemiological evidence, plus some, experimental evidence, such as in animals. Although that animal toxicity doesn't necessarily correlate, as I'm sure we all know.
Something I'll just add is that the body is incredibly complex, and so you would imagine trying to draw a causative link between one particular exposure and one particular cancer risk is extraordinarily difficult. And it requires looking at thousands, if not tens or hundreds of thousands of patients. And you imagine all the different types of environmental factors we might run into on a daily or weekly or monthly or yearly basis. It becomes incredibly difficult to sometimes group some of these things into absolute causative, absolutely have nothing to do with cancer, and then all the gray that's in between. And it's a question that I think has a lot of importance going forward as we try to understand not only a particular person's cancer risk, but also trying to get a better sense of understanding on the population scale the etiology or the initiation of these different types of cancers you see in different tissues. And that's a lot of what my research has been into, has been trying to develop tissue simulants that we can do a lot of this work outside the body to hopefully get a little bit of a better sense of some of the initiation signals. But again, it's when you think about the different groups that you can link these exposures or different chemicals or radiation into, it's very difficult sometimes to draw 100% causative links one versus the other. A lot of times you have to, look at the data and think whether or not you use a little common sense sometimes and think whether or not it makes sense for you to be exposed to high levels of radiation. Probably not. Some other things, it's a grayer. There's a lot more shades of gray.
And that's actually what I want to make sure that people understand, because just coming into contact with something on the, A to C list, that doesn't mean you're automatically going to develop cancer.
Oh, sure. I mean,
Right.
we have a saying, the dose makes the poison, but it's more than just the dose. It's the dose and time of exposure. For instance, and I can't resist going back to my old favorite bugaboo of the anti-vaccine movement. They will frequently say, "Oh my God, there's formaldehyde in vaccines." Well, the amount of formaldehyde in a vaccine is tiny, and it's way below what infants actually make through normal metabolic processes. So when formaldehyde is listed as a carcinogen, for instance, we're talking much higher concentrations and prolonged exposures than that. So I mean, that's the sort of basic misunderstanding of epidemiology that, for instance, various pseudoscientists like to use to scare people.
Exactly. And you could also look at, X-rays or radiation
Sure.
exposure. It's all about how much, how long, and when. I mean, it's radiation is, I was as a personal note, I was treated for leukemia when I was in high school. And one of the treatments was total body irradiation, which was incredibly important to kill the cancer I had. And you try to manage they try to manage the radioactivity exposures so that you have, you can kill the disease that you have and also have long-term efficacy, but also not go so high that you're nuking yourself beyond any sort of level that you can come back from. And so it's all about, a lot of it, unfortunately, it has to do with dosing and time, and that's again what makes a lot of this so difficult to, there's not one thing we can point at and say that's the cause for all cancers, or that's the cause for even one type of cancer. Absolutely.
Sure, and I mean, even go to my specialty of breast cancer, there's a great deal of interest these days in whether exposures at certain critical times in development are linked with breast cancer. For instance, during puberty, and that's incredibly hard because most breast cancer is still, by and large, mainly a disease of older women. It's not a very common disease below the age of 40, although we certainly see it, but it's not that common. So, you're talking differences in 25 to 45 years between the exposure and the actual cancer. Imagine trying to study that.
You're listening to Skeptically Speaking. Today's topic is cancer, with oncologist David Gorski and researcher Brendan Harley. So I am very interested in cancer clusters. Can somebody explain those?
Cancer clusters are, it gets back to what's the cause for cancer. And so there's been a number of cases that have made the media over the last 20 or 30 years. Oftentimes it had to do with water contamination, but had to do with this idea that there was some local environmental hazard that came into place, either due to chemicals released into the environment. Actually, that was usually what it was, that created some environment that would lead to a higher cancer risk in that one location as a function of whatever the environmental exposure was. And I remember there was there's some cases out in California, and as well a classic case back in Massachusetts, actually, where I grew up, that had to do with exposure to the water. And actually, as it turns out, my dad is a civil engineer who does a lot of work at groundwater modeling. And so it's, even when you imagine there, it again gets at, what has maybe been released and would cause a local environment, but you have to worry about how did people get exposed, how much did they get exposed to, if it was some chemical release that maybe got into the water, how long does it take for it to move through the underwater aquifers to actually affect the population. Again, it's incredibly hard to detect sometimes because you're talking about a change in the number of cancer patients locally, but you have to think about it in terms of population statistics. Just because you bought a new Volvo doesn't mean there's more Volvos around because you start seeing them. It means you're maybe more hyper aware to them as well. And I'm not trying to discount the idea of a cancer cluster, but it's very hard to sometimes pull apart because of the population.
There's something known as the Texas sharpshooter fallacy. It comes from the idea that someone who's a horrible shot shoots a bunch of times at the wall, and there's they're naturally, just by random chance, some of the holes will cluster, and then he goes up and draws a circle around the cluster and says, "That's it." Looking for cancer clusters is very prone to this. Most of these things are just random variation, and it's really, really hard to tell what isn't random variation.
How do you figure that out exactly? Because, here in Alberta with the tar sands, we have First Nations communities that are saying they're seeing higher rates of cancer due to the pollution from the area's oil production. You've mentioned a bunch of variables there, but how do you figure out if that's actually the cause?
That's an incredibly difficult question. I mean, high-level epidemiologists will argue about this. It requires some really difficult and hard, epidemiological studies plus some toxicology studies, and it's not easy at all. It's very difficult.
And this is not to discount the idea that there could be clusters. Because
Oh, no, I'm not.
There's a lot of ways in which what we're doing is hard to detect, and we're trying to, as a scientist, I want to make sure that I can say absolutely what we're measuring is what we're doing. And we do a lot of experiments that we can set things up and you have good controls and it's possible to answer those questions. But when you get into this, it's incredibly difficult to do. And there's probably a lot of places where cancer clusters have not been identified that absolutely exist, and probably places where cancer clusters do not exist, but maybe have been suggested to be. And it's very difficult to tell the difference between the two.
Okay, so it is very difficult, obviously, to tell how cancer was caused in the first place. So how about cures? Now, David, you mentioned that the idea of a cure for cancer is sort of a flawed idea in the first place, what with it being cancers. So how are we currently treating cancer?
It depends upon the cancer, of
Indeed.
course. But most solid tumors, the treatment is surgical if you can resect it. If you can't, then it's a combination of chemotherapy and radiation. Now, the unfortunate fact is for most solid cancers, if you cannot surgically resect the primary cancer, the chances of curing it are quite low. That's the final frontier in cancer, is how do we take care of stage 4 disease, which is basically disease where it's spread beyond, well beyond the original organ. But, for most of it's either a combination of surgery, chemotherapy, and radiation, and more increasingly targeted therapies that are aimed at specific abnormalities in gene expression or specific mutations that are driving tumor growth. So the idea of targeted therapies is presumably, and in many cases, they're less toxic, which is, of course, the big problem with a lot of our treatments right now.
Well, which cancer has the highest recovery rate?
Oh.
Do you guys gauge stuff like that?
I'm not sure I know the answer to that one. However, I can say that my specialty, breast cancer, if you have stage 1 disease, you have like a 90 to 95% chance of, living, greater than 5 years, and about a 90% chance of living, 10 years. So that's a pretty good record. I could tell you the worst cancer, some of the worst cancers.
Oh, do scare me, please. That sounds
pancreatic cancer.
Okay.
Esophageal cancer. Those are two of the bad ones.
Gliomas, another bad one.
I'm not a neuro-oncologist, so those don't come to mind as quickly as the other two. But
we do some research on those, and those are another one I'll add to that list.
Oh, good.
But I mean, pancreatic cancer, if it's resectable, you can get maybe a 20 to 25% 5-year survival rate. If it's not resectable, it's pretty darn close to zero.
So I should never ask those questions because they're just depressing. So, Brendan,
yes.
Let's talk about your research, because what you're trying to do is make those treatments more effective, right?
As you might have sensed, the theme that we've been talking about is that a lot of the issues surrounding cancer are incredibly complex,
right, and
difficult to pull apart causative versus related actions, and it's biology is innately very complex. And so my research group, actually, one of the major areas of our research is to try to develop tissue biochips, as we're calling them. So you can take cancer cells out of the body and put them in a petri dish and grow them in an incubator, and there's lots of some of the seminal work that we understand in terms of mechanisms associated with the etiology of some cancers, progression of cancers, malignant transformations, has come from studying cells sitting in flat plastic stiff dishes that are sitting in the incubator.
2 dimensions is what we say.
Right.
It's funny that he should mention this, because I'm collaborating with someone where we are working on these 3-dimensional culture techniques for breast cancer. But go on.
Yeah, so that's a lot of what we do. We're a biomaterials lab by design, and so we've come into cancer mainly just out of my own interest in trying to develop new systems to work on it. But the idea is, can we create 3-dimensional culture environments that are still amenable to a lot of the fancy analytical things you can do from cells sitting in a petri dish, but allow you to reduce some of the complexity in biology into manageable series of variables in order for you to look at how the environment affects some of these cancers in terms of growth. And so one of the major ones we're working in is glioma, so that's brain tumor. So it's one of the more common forms of brain tumor and has incredibly low survival rates. And one of the reasons why is that glioma cells, they don't metastasize to other tissues, but they spread out throughout the brain quite readily, so you can't resect them very effectively. And so one of the thoughts that people have is that there's some immunotherapies that might work very well, some immune cells that could be targeted to kill the cancer cells, and it's not worked very well when we've actually tried them in vivo in the body. And so we've been trying to build these basically optically translucent little bits of jello that we can culture cancer cells surrounded by an environment that mimics the brain tumor matrix very effectively. So we can look at how the environment impacts malignancy and how the environment mitigates the ability for immune cells to target these glioma cells. So admittedly, it's a simplification of cancer, but allows us to actually recapitulate some of the complexity and heterogeneity you see within tumors and allow us to ask questions about how do you design immunotherapies or other therapies to work more effectively on these glioma cells, because they work great on glioma cells in a dish and it never translates. So we're trying to bridge that gap between what is currently done outside the body and what happens inside the body.
We have a question from the chat from Insider.
Do cancer cells in general live forever? Some are grown in labs for over 50 years, and I'm wondering if that's a general rule.
It's referring to immortalization, which basically is the ability to replicate without end. In normal cells, what happens is there's the end of the chromosomes, which are called telomeres, get shorter with each round of replication, and when they get below a certain length, the cell becomes senescent and can't replicate anymore. Cancer cells have ways of getting around that.
It's not absolute, I'll say. For David already mentioned this once before, that you need this process of angiogenesis, new blood vessel formation.
Sure.
So you can take as malignant of a cancer cell you want, and you grow it in our biomaterials. If we grow these biomaterials to a certain scale where they're diffusion limited, those cells are not going to survive, even though they're cancerous. And so there's always restrictions, but theoretically, left in some sort of ideal environment where the cell is bathed in the perfect combination of media supplementation, you can keep them alive for quite a long time. But my grad students have been known to kill cancer cells quite effectively by accident. So
well, I always tell people, for instance, I can kill cancer cells in a dish to my heart's content by throwing a little bleach in it, but you can't use that for treatment.
You're listening to Skeptically Speaking, and I'm talking about the Big C with oncologist David Gorski and researcher Brendan Harley. And we'll be right back after these messages.
Skeptically Speaking wants you to question everything. To be a part of the discussion, call and record your question on our listener question line at Speak 73101. That's 773-257-3101. Long-distance charges may apply. Sunday nights at 6 Mountain Time, join our Ustream chat room to listen and ask questions as we record interviews live. Just click the Listen Online button at skepticallyspeaking.com. You can also email your questions and comments to live@skepticallyspeaking.com, or if you're on Twitter, tweet us at Skeptical Radio. To find out where Skeptically Speaking airs near you, to listen to past episodes, or download the weekly podcast, check out our website at skepticallyspeaking.com. While you're there, follow the links to connect with us on our Facebook page, our Twitter feed, or to subscribe to the show in iTunes. And now, back to the show.
Welcome back to Skeptically Speaking. I'm your host, Desiree Schell, and today I'm talking to Brendan Harley, who is researching material platforms to study the initiation and progression of diseases like cancer. Also with us is Dr. David Gorski, surgical oncologist and managing editor of the brilliant Science-Based Medicine website. Okay, so one thing we do have to definitely get to is alternative cancer treatments, and you can't see my air quotes. I had an email from someone a while back, and his partner was receiving treatment for breast cancer. And a family member gave them something called a spectrochrome therapy lamp, which came with a bunch of colored gels and a book telling you which color works for which disease, and a huge stack of boxes of Immunocal, which I have no idea what that is. Have either of you heard of this?
I have not heard of that, although I've heard of things sort of similar to it, or like the color determine. I mean, it's pretty obvious nonsense, I'm afraid, but I just
there's a lot of variations of the same theme.
Right. I'm assuming both of you see some of these treatments in your research, specifically ones that don't work, but people keep trying anyway.
Oh, yeah. Some of the common ones, the Gerson therapy, you may have heard of.
I did an interview on that. That is some scary stuff.
It's basically like quote-unquote nutrition, but it basically involves lots of vegetable and fruit juices and meat extracts. And
you're missing the best part, sir.
No, I was getting to that. Coffee enemas. But yes, coffee enemas.
That was the one.
At least once a day. I think it's once or twice a day.
And, I did look into that at the time, and there was effectively no evidence behind that. And those kind of cancer cures have exploded. And really what we're talking about here is the problem. When you're diagnosed with cancer, you are in a decidedly vulnerable state. Especially if you have one of the cancers that particularly scare me, the lower rate of recovery ones. So it is understandable that you'd want to try everything and anything, right?
And I think that's what people rely on. It's not only that you're vulnerable, but you're desperate, and your family members are desperate. And, speaking as someone who's gone through treatment, fortunately, I never had to deal with anything like that, but it's incredibly easy to see these types of things take hold. You hear someone heard of someone who got better because they took this, whatever this vegetable extract was, and it's, it runs like wildfire through groups. I speak at American Cancer Society events, and I have oftentimes people coming up afterwards asking me about, combinations of vitamins or other things that they heard someone had heard. And and I'm not trying to discount it, but the danger is that people rely on these as they could be cures, and they pay a lot of money to people that are of dubious background in order to get these so-called cures. And it's incredibly sad.
And people ask, well, what's the harm? You got pancreatic cancer. What do you have to lose? Well, I'll tell you what you have to lose. For instance, with the Gonzalez therapy, which is basically a variant of the Gerson therapy, that's basically you can lose a shot at palliation. I mean, there are, they tell you to do this and don't take conventional medicine and the like. And instead of undergoing treatment that can at least palliate, your symptoms, you're basically dying of untreated cancer with no palliation. It can be incredibly harmful, even if you have one of those low survival cancers.
So then how do lay people differentiate between a treatment or a therapy that is total bunk and one that might be something that just doesn't have the evidence behind it yet, especially in that vulnerable kind of condition?
Look at the claims. Do they, for instance, do they promise a cure for an incurable cancer? If it sounds too good to be true, it probably is. Another thing is it offered in reputable cancer centers? Is it offered as clinical trials in reputable cancer centers? Then it might be, that might be quote unquote cutting edge therapy, as opposed to it's being offered in some clinic in Tijuana, which is where a lot of those clinics are. Right. So, those are a couple of things that come to mind.
And it's hard as a family that, if you have a member of your family going through cancer treatments, it's very easy to think, I could try anything. I'll try whatever I possibly can. And it's, there's times where you have to make sure you talk to your medical team or the doctors you're involved with. This is not to say that there's some things that are, that are outside of the realm of medical treatment that could be incredibly helpful. What I tell all the cancer patients I've run into is one of the most important things you can have as a patient is a positive mental outlook on things. I know that there's not a direct cure between the two, but you go through so many horrific treatments or horrific situations as a cancer patient that your ability to keep positive and keep mentally focused and motivated, it helps your capacity to process everything that's going on. And whether that leads to better cure or not, who's to say? But, it's having the ability to stay connected to the process is important, but it's not a cure. And so you've got to make sure that patients have access to information and have access to credible information and the ability to talk to medical professionals about options.
You're listening to Skeptically Speaking. We're talking about cancer with surgical oncologist David Gorski and researcher Brendan Harley. Now, there are some preventative measures that we can use with some cancers, like with the HPV vaccine. So if someone could explain how that works?
Certain subtypes of HPV have a are associated with a much higher increased risk of cervical cancer. So if you can prevent infection with those particular serotypes of HPV, you can dramatically decrease the risk of cervical cancer, and that's where the HPV vaccine comes in.
So then why don't we have vaccinations for all cancers?
Well, it comes back to cause and effect. The HPV, there's good evidence linking, those specific serotypes of HPV to causing cervical cancer. Most cancers, we don't have that sort of a nice magic, quote unquote magic bullet as far as a target to make a vaccine to. So now I'll tell you another preventative vaccine against hepatitis B. I mean, you get hepatitis B, that greatly increases your chance of getting liver cancer, which is a really bad one. So, I mean, there are other vaccines that can be viewed as cancer preventative, but it's not as common, obviously, as we would like.
We have a question from Landon.
How can an infection cause cancer?
I won't talk about the HPV necessarily. Maybe Dr. Gorski can talk about that. But there's some literature to suggest that, just some types of infections, will compromise your immune system. And so that affects your body's ability to recognize and defeat some cancers early on, or some mutations that might eventually lead to a cancer early on. And so separate from what might be exact causative links between some sort of infection and a particular form of cancer, having enough of an infection load in your body can also distract the immune system effectively from its ability to weed out, identify, and destroy cells with certain forms of mutations.
I mean, there is a well-known now link between chronic inflammation and cancer. And infections can cause chronic inflammation. Mm-hmm. So, for instance, the acid reflux can cause a condition in the esophagus known as Barrett's esophagus, which is a premalignant condition that can progress to esophageal cancer. There's a phenomenon known as Marjolin's ulcer, which can happen after a burn wound, which basically is a chronic inflammatory reaction that can turn into skin cancer. I mean, there are a lot of examples of this, and then some viruses some viruses can directly transform cells. So it's inflammation and infection in certain cases, for certain cancers, not all cancers, can contribute or cause the development of cancer.
This one is from Tiffany.
How does cancer spread to other parts of the body? Do the cancer cells actually cause normal cells to turn into tumors?
One of the primary ways that they spread is a process called metastasis. And so that is where you have a primary tumor mass that has lots of tumor cells inside of it. And there's a lot of different reasons why a cancer cell within that mass might get this signal, but there are different types of signals that will cause individual cancer cells or small numbers of cancer cells to detach from that tumor mass and make their way either through the tissue to other local sites, or primarily getting into the bloodstream and floating around and finding their way to other tissues. So you see breast cancer metastasizes to lots of tissues. You see in lung or bones. And so you actually have cancer cells from your original tumor mass setting up shop somewhere else in the body and expanding and growing and doing exactly what they did in the initial tumor mass.
It's actually a fairly inefficient process because the vast majority of cells that detach to the tumor don't have what it takes to set up shop elsewhere. But when they do, that's what kills patients. I mean, the primary tumor, at least for solid tumors, I'm not talking about the hematologic tumors, but the primary tumor rarely kills the patient. It's usually the metastases.
All right, and the last audience question, will be from Insider, and he gets 2 because this is a really good question.
Can you please talk about tumor suppressor genes and their relation to epigenetics?
Tumor suppressor genes are genes that normally keep cell growth in check. So, that's their job. So when they are lost, cancer can develop. Now, I'm not really an expert on epigenetics. I don't know if Brendan knows more about it than I do, but epigenetics are ways that are not directly tied to the genome that for regulating gene expression, and there's been a lot of interest in it lately. I wish I could give you a better answer than that.
There's a lot of different regulatory steps within a cell that's part of this process where cells make decisions about future behavioral changes. And the idea of these tumor suppressor genes are things that can enhance the body, enhance the ability for to prevent some sort of tumorigenesis process. And epigenetics is sort of this study of heritable changes within the body. And so there's a question about what is it that is specifically genetics based, so the DNA code that's inside the cell is driving a process, versus some variations in that code, versus some environmental factors that impact tumor suppressor genes' capacity to behave. And so there's a lot of this. There's been a lot of studies looking at cancer etiology, for example, that are identifying downregulation in some of these tumor suppressor genes. At the same time, you see increase in cancer. And so this is obviously at a single cell level, but you get enough cells that have the inability to suppress some early stages of tumorigenesis, and you end up with the development of a cancer.
I've decided to give one last question because it's good too. This one's from Gravespinner.
We probably all know people whose physicians have suggested to wait and see how it progresses. Are there studies to show that immediate and aggressive treatment is always preferable?
That's an incredibly complicated question.
Well, I'm surprised.
There is a point of diminishing returns. This brings up the issue of overdiagnosis and overtreatment. For instance, in breast cancer, there's a phenomenon. There's a question as far as whether treating the earliest stage cancers actually makes as big of a difference as we think it does. For instance, ductal carcinoma in situ is viewed as being pre-malignant, but it doesn't always progress to cancer. And the problem is we don't know which DCIS lesions will become cancer and which will just sit there and not really do much of anything and never harm the woman during the rest of her life. So we treat them all the same. On the other hand, if you have a more advanced, a cancer that's further along, we can be pretty darn sure that if we don't do anything, that it's going to continue to progress. And in those cases, treating it, aggressively, can indeed result in prolonged survival and a better chance at a quote unquote cure, or however you want to define it, greater 5-year survival, 10-year survival.
As I mentioned before, I was treated for leukemia. And there's multiple types of leukemia, as one might imagine after hearing the course of the hour. But there's
more than I can remember from my medical school.
There's certainly a lot. But there's a transition between chronic and acute forms of leukemia. And so even I had a form of acute myelogenous leukemia, and there's a chronic version that is treated much differently than the acute version, because patients can sort of live along with the chronic version for years. It's when the chronic version becomes acute that you have this massive transition and a need for pretty heavy duty treatments. And so one of the questions you have, at least in that disease, is, a lot of the treatments for leukemia are pretty heavy handed. I mean, I had massive radiation doses and chemo doses. So do you want to give those treatments to a patient who's maybe 60 and has chronic myelogenous leukemia and can be managed with some degree of their quality of life maintained for quite a period of time? When do you go in with the giant hammer that is a lot of the current treatments we have, And sometimes it's, you got to get in there. In my form, I was diagnosed at 7 p.m. on a Friday night, and at 9 a.m. the next morning, I'd already had a catheter inserted and was starting chemotherapy. There's other patients who can spend months or years.
No, that actually reminds me, prostate cancer. Increasingly, we're taking a more hands-off approach, or a less aggressive approach to prostate cancer, early stage prostate cancer, that used to get radiation or even radical prostatectomies, 10, 20 years ago. We are now doing what's called watchful waiting, and it's turned. There are studies to show that that's safe. And it's becoming more and more the standard of care for low grade, early stage prostate cancer, because a lot of prostate cancer will never endanger the life of the man. It's the problem, of course, is figuring out which ones will and won't. But if you look at autopsy series, about something like 80% of men over 80 have foci of prostate cancer. They don't all die of prostate cancer, obviously. Most men don't die of prostate cancer. It's just something that happens that doesn't endanger the lives of most men. So we were probably treating a lot of men with invasive surgery and radiation who didn't need it. And we're only now starting to figure out whom we can watch safely and intervene if it starts showing signs of progressing, as opposed to just treating everyone, with a one-size-fits-all sort of approach.
Just one last thing is that there's a lot of sense now that with the potential to have experimental platforms to do almost individualized medicine on patients, there may be ways in the future where cancer becomes a chronic manageable disease, some forms of cancer at least, where it's not cured, but you can live with it for long periods of time with the right management. And maybe that's just as good of an approach than trying to eradicate it at all costs, because the treatments have very significant side effects associated with them.
We have, again, covered a terribly complex issue, and we are totally out of time. So thanks very much to both of you for being here.
My pleasure. Thank you.
Thanks for inviting me.
You'll find links to Dr. David Gorski and Brendan Harley on our website at skepticallyspeaking.com. And we'll be back to talk about breast cancer, mammograms, and those ubiquitous pink awareness programs with author Kayt Sukel after this.
On the next episode of Skeptically Speaking, we're looking at the lighter side of science, both real and imagined. We're joined by Mark Abrams, editor and co-founder of the science humor magazine Annals of Improbable Research, the father of the Ig Nobel Prize ceremony, and author of the new book, This is Improbable. Researcher and blogger Cy Curious returns to share more of her favorite Friday Weird Science posts. And we'll talk to Phil Edwards, author of the Fake Science blog and textbook. That's next week on Skeptically Speaking, on your local radio station, or online at skepticallyspeaking.com.
Welcome back to Skeptically Speaking. I'm your host, Desiree Schell, and I'm here with Kayt Sukel, science writer and author of Dirty Minds. Welcome back, Kayt.
It's a pleasure to be here. Thank you for having me.
So a while back, I received a Facebook message from a listener asking me to please find a guest that could talk about mammograms, because there seems to be a lot of conflicting information out there about them. So maybe let's just start with what mammograms are.
Sure. And I mean, your reader is right. There is a lot of conflicting information. And also there's a lot of marketing information mixed in with the science information, which I think can even make it more difficult to sort of tease apart what is really out there. So at its simplest, a mammogram is just a special type of x-ray that has been designed to look at the breast tissue. Because obviously, breasts have a lot of fatty tissue in them. They come in all shapes and sizes. So basically, there's this special x-ray machine. Each of your breasts is placed between an x-ray plate and a plastic plate. These compress the breast to flatten them as much as possible to basically, minimize that fatty tissue so they can look all the way through the breast. And then, it just looks the same way just an x-ray would for changes, like abnormal tissue, little bumps or things that shouldn't be there.
So if they find something that shouldn't be there, then what's the next step?
It sort of depends on what they find. And I will just apologize to everybody in advance because a lot of my answers are going to be sort of, it depends. And this is where it's important, where you have to be your own advocate for this kind of stuff and speak to your physician about it and ask questions. Ask lots of questions. Be annoying. Because this is your best bet. You are your own healthcare advocate, especially when it comes to your breasts. So if there is some kind of lump or some kind of dense tissue, they may say, well, we see a little shadow, we see a little something there, but we don't think it's anything to worry about. Come back next year. If it looks bigger or if it looks different, then maybe we'll do something. If, the radiologist takes a look at it and sees something that's more concerning, you may be asked to do one of two things. You may be asked to come in for an MRI of your breast, which allows basically greater detail. And to sort of, the same way that you would get an MRI of your head, you actually get an MRI of your breasts. You lay face down on the table, and instead of your head being strapped down, you're face down and your boobs actually kind of hang down through the table. It's a special breast MRI setup. And they look at them that way, to see whether, a spot or something that was seen on the mammogram was something to be worried about. Or they may also just go straight to a biopsy, where they could do it with a needle, or they might do it with a scalpel, but they'll go in and take a sample of the actual tissue and then send it to the pathologist to see if there is a tumor or some kind of other, tissue malformation that they need to take a closer look at.
Now, is there a difference between a mammogram and what we hear called a breast cancer screening?
A mammogram is a type of breast cancer screening. You'll often hear the term screaming mammogram, not screaming. No, and actually, I just had my first mammogram after my mom's diagnosis, so I can speak to the experience as well if you want to hear about it. But sometimes they will call us a mammogram a screening mammogram because that's what they call it for women who have no symptoms of breast cancer. If you're just sort of coming in for a screening, then it's a screening mammogram. A diagnostic mammogram would be for somebody after a sign of some type of breast cancer has been found. So for me, I go in for screening mammograms right now because I have no evidence of the disease. My mom, who's already been treated for the disease, now goes in for diagnostic mammograms. It's just a wording change, and it's just something the doctor may throw around. But there are all kinds of breast cancer screenings. That MRI that I was talking about is a way to screen for breast cancer. Doing your self-breast exam is a way to screen for breast cancer. Your doctor giving you the touch exam during your annual, well women's visit is a type of screening as well.
Now, you mentioned that you might want to talk about your experience, and actually this seems like a really good time to do that because in addition to all the media misinformation about it, a lot of people, especially if they're younger, might not actually have anyone to talk to about that. So what is it like? Actually,
I have to say I was sort of pleasantly surprised. Yes. I thought that it was going to be very painful because a lot of people that I've talked to have said that it hurts a lot. And I will say it's not exactly pleasant having your boob placed between two plates and flattened out. I'm not going to put it up there on that top 5 things that I want to do. But it's only for a few seconds. It is a little squeezy. It is a little pinchy, but, the flatter the breast, the better the picture, the more they can get out of it, the less frequently you have to come back. So really, your screening mammogram, it took me about 15 minutes. At most, it's probably going to take about 20 minutes from start to finish. And if you pop a couple of Advil before you go, it probably won't even bother you as much as everyone says it will.
Okay, so here's where it gets sticky.
Yes.
Now, I've read articles, as well as I'm sure my listeners have, that breast cancer screening is pretty much the best thing that a woman can do for herself in terms of preemptive strikes against cancer. And then I've also read, of course, that it's totally unnecessary for most women. It has a substantial rate of false positives, and basically going for breast cancer screening will just freak you out for absolutely no reason. So it cannot be both of those. So which one is it?
Well, actually, it is kind of both of those.
Oh, good.
Which I think the caveat that I need to start with is breast cancer, we talk about breast cancer like it's one thing, but there are different types. There are types of tumors that have a genetic basis, the BRCA1 or 2 gene variants that is linked to, a certain type of breast cancer and also ovarian cancer. But basically, even when you're talking about any cancer, no tumor progresses in the same way. And that's where it makes it kind of difficult. So I do think, if we go back, the United States Preventative Services Task Force, they recommend every 2 years, starting at the age of 50. Now, it was very much when they came out with these guidelines in 2009, it was hotly contested because, of course, we've all been told forever that starting at 40 every year, get those bad boys done. And, the thing is, we just don't know enough about who's going to develop cancer. And it really depends on sort of who you ask. And I think that the most important message that's based in the science that everybody's saying, but all of the readers and media outlets tend to ignore, is this is something you need to talk to your physician about. Based on your family history, based on your lifestyle, based on your own sort of physiological characteristics, this is something that you should be talking to your doctor about. When you go in for your pap smear, you should say, hey, when should I be doing this? And talk about it with them. Again, because tumors don't progress at the same rate, the task force made its decision based on who's most likely to die. And, you're not, if you get a mammogram every 2 years starting at 50, then chances are you're not going to die. But then other studies have tried to look at other factors, because obviously with cancer, it's not just about whether or not you end up kicking the bucket, right? I mean, it's also about what kind of options you have open to you for treatment. So there are a lot of false positives. Most of the women that I talk to, they get a little sort of uppity once they're told, we saw something in your mammogram, you need to come in for the MRI or the biopsy. But after that 2-week period is over, they're cool. It's not really a huge psychological harm. Other, people will tell you that you could have a little something on there, but it might not ever go anywhere.
So basically the answer is, it depends.
It depends. And, people don't want the it depends answer.
No one does. But as in most areas of science, there's a lot of nuance. There's a lot of gray.
There is. And I think, again, it's really important to talk to your physician about it. And I think they're happy to talk to you about it. And of course, the science, it sort of, gives different points of view. Very recently, just a couple months ago, there was a new study that came out that looked at approximately 1,800 women in Europe. And it was published in BMJ, formerly the British Medical Journal. And what they found was that extra radiation from annual mammograms might be bad. It actually may raise the risk of developing the disease. But they were only looking at those who tested positive for that gene variant, BRCA1 or 2. And because of the way that particular type of cancer develops, that's different. That's important, right? So if you have a defect in BRCA1 or BRCA2, you may have increased radiation sensitivity.
Right.
These are genes that are involved with the repair of DNA breaks, and DNA breaks can be caused by ionizing radiation, which is what mammograms basically and x-rays basically are. So that may increase that risk. So, if you have that kind of genetic mutation, right now in Europe, they're already saying you go straight for MRI. You don't get the mammogram. But when I actually talked to the authors of this study and I asked them directly, there's been so much debate in the U.S. about whether women under 50 should or should not have their mammograms. What do you think this study adds to the ongoing debate? They were very clear. They said our study is focused on a small group of high-risk women. It does not apply to the general public. Our study cannot contribute anything to this current debate on population-based screening below the age of 50.
You're listening to Skeptically Speaking, and I'm talking about mammograms with science writer Kayt Sukel. Okay, so since I have you here, I'm going to ask about something sort of tangentially related because it is Breast Cancer Awareness Month. So I do have to ask, what do you think about let's call it the pinkification of breast cancer?
I got interested in this when my mom was diagnosed with breast cancer late last year. And so going with her to her doctor's appointments and talking to a lot of these really incredible oncologists and nurses that have been working in the field, 20 years ago, people would have never said breast cancer. This was not something that you would have talked about with your doctor. This is not something that was out in public. So you have this leading killer, this leading, disease that affects women so profoundly, but nobody talked about it.
Right.
So I think where these organizations started was in a really good place. I think that breast cancer awareness is very important. I think women, becoming their own healthcare advocate, asking these questions, talking to their doctor to see what's best for them is so important. And this came from many of these organizations, Komen being one of them. Mm-hmm. That being said, at this point, it's really hard, as I said earlier, to tease apart the marketing from the medicine. And I think that is really confusing for a lot of women. And I worry about that. And I'm hoping that people, are not embarrassed to talk to their doctors and to their clinicians and ask the right questions and not just sort of, limit themselves to what's on a ball cap or a, cozy for their beer.
Right. And I guess that's the answer there is it really the case that in North America there is someone out there who has never heard of breast cancer?
I'm afraid to answer that question because as soon as I say no way, there's going to be somebody.
That's true. That's true. Let's say the majority, vast majority, potentially.
It's like I hesitate to liken organizations like Komen to labor unions, but in a sense, they started from a really, really good and really, really important place. And maybe they're still sort of trying to figure out where they are now.
So we're all about breast cancer awareness reformation.
Again, a lot of these organizations, they do a lot of great things. They fund a lot of great research, and I applaud that. I think that's fantastic. But, I think there's also sort of a darker side where these organizations sort of become the face of the science as opposed to, the researchers and the clinicians actually doing the science.
And that's actually my concern is when we donate money, are we donating money to painting drills pink, or are we donating money to the actual research to the end of breast cancer?
And that is something an accountant would have to go through with you because I don't know the answer to it. I mean, I think that, again, 20 years ago, and I don't think that I really realized it at the time, although I guess 20 years ago I was pretty old, so maybe 30 years ago. But, people really didn't talk about it at all. And women were not realizing that they had an issue, that lump in their breast was going to kill them. They weren't finding it until it was, too big to really do anything about. So I think that awareness is important to a certain extent. But I think we are pretty aware at this point. And yeah, it would be great if there was more money from the government that could go to these things. It would be great if, the organizations were self-policing in some ways, if it was transparent where we could see where all those dollars go to.
So obviously the cure for breast cancer then, let's say, is a valiant objective, and maybe if you're planning to donate, maybe just check Charity Navigator, and that's charitynavigator.org, I believe.
I think that's a good idea. I think do your homework, do your research, and find organizations that also, of course, the other problem with Komen, I am a die-hard and devout Planned Parenthood supporter for a million reasons. And, Komen's political decisions to stop supporting them earlier this year, there was a backlash. But again, I think, charities and these organizations, do your homework. What kind of organization do you want to support?
Kayt, thank you very much for being here and helping us straighten that out.
Thank
Mostly.
you. And again, everybody, please women, talk to your doctor, even starting, in your 20s and your 30s. If you have a family history, if you have, make sure you fill out those forms. Make sure you talk to your doctor. Make sure you ask. Because you may not realize that your grandmother died of breast cancer. She might not have even known it. But even putting on your forms that I have a grandmother that died of something we don't know about, that can be important information that can help fuel that discussion with your clinician. So do it. Don't ignore it.
Says Kate. Good.
Yes.
We've included a link to Kayt Sukel and her writing on our website at skepticallyspeaking.com. While you're there, do please click the links to Facebook, Twitter, and Google+, where you can keep up with show news, and to iTunes, where you can subscribe to the program, listen to past episodes, or leave a review. Thanks for listening, and we'll see you next week on Skeptically Speaking.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is. 'Cause we're skeptically speaking.